Hey guys, what's up? I just got home from school and I was really bored and thought it was such a pretty day that maybe we could go outside and do a cool experiment on the scientific method with paper airplanes. So I got to wondering, would the type of paper I use to make a paper airplane affect the distance that my airplane would travel? That is an awesome question, isn't it? So, before we start, let's kick it back way to the beginning of the school year whenever you guys learned about the scientific method. The first thing we have to do before we can even start an experiment is we have to ask a question. So like I said a minute ago, my question is, will the type of paper that I use to make a paper airplane affect the distance that my airplane will travel? So as scientists, it's really important that we always write our super cool information down. So I wrote my question, does the type of paper have an effect on the flight distance of paper airplanes? So next I gathered my supplies. For the paper airplanes, I'm going to use, notebook paper, newspaper, and regular copy paper. And we're going to see which one will fly the farthest. Now that I've gathered my supplies and I have everything I need to get started, I've got to come up with a hypothesis. And a hypothesis is just an educated guess what I think is going to happen before I actually see it happen. So my hypothesis is the paper airplane made of notebook paper will fly a longer distance than the ones made of printer paper and newspaper. So I think the one made of notebook paper is going to fly the farthest. So now that I have formed my hypothesis, we can almost get started with our test. But first, we've got to talk about variables because those things are pretty important. You guys remember independent and dependent variables and constants? They are a crucial part of all experiments. So first, let's talk about independent variables. Independent variables are the thing that we're going to be testing. So in my experiment, it's what I'm going to change. So the independent variable is going to be the type of paper that I am using. Next, we need to chat about the dependent variable. Now, the dependent variable is kind of confusing. A lot of people get the two mixed up, but the dependent variable is kind of like the result. It depends on the independent variable. So our dependent variable is going to be how far the airplane flies. Now let's talk about constants. Constants are probably one of the most important parts of an experiment because if you don't try to keep everything else the same, it could totally mess up the results of your experiment. So let's think about the constants in this experiment. So first I'm going to have to make some paper airplanes. So when thinking about constants, I have 3 different kinds of paper. That's the thing that I'm changing. But I'm going to have to keep some things the same. What I'm going to have to do is I'm going to have to make sure that I use the same exact size piece of paper for each of these. I'm going to have to do some cutting. So after I cut the same size piece of paper, I also have to make sure that I make my paper airplanes the exact same way, because if one's different, it might fly a little bit further. So I'll be right back. So I made my airplanes and they're all the same size, same design, same everything. So now we're going to throw them, but we also want to make sure that we're throwing them with the same force, because if you throw one harder, it's obviously going to fly farther. So we'll try our best to throw them the same. Again, it's really important that we write all our information down, so I wrote down our variables. The independent variable is the type of paper we're using, the dependent variable is the flight distance, and our constants are the size of the paper, the design of the paper airplane, and the force of the throw. Okay, so now we're going to throw our paper airplanes, and I got some help. This is Tanner. But it's also really important that we test things multiple times, so we're going to try each airplane 3 times and see which one goes furthest. And we're going to record our results. Okay, so Tanner's going to throw our paper airplanes the exact same way every time. Ready? Go. That was the newspaper. Go. That was the notebook paper?
Yeah.
Okay. All right, last one. Go. And that was the printer paper. Okay, so test 1 shows that the notebook paper went the furthest. Not by much, but it went the furthest. We're going to test it 2 more times and see what happens. So we came back inside and I recorded our data into a chart, and now it's time to analyze our data. So that means that we just have to look at it and see what happened and break it down a little bit farther. When we test things multiple times, we call that a trial. So we ran 3 trials on our paper airplanes to see which one traveled the farthest distance. In trial 1, the notebook paper traveled the farthest, barely beating the newspaper, and the copy paper was very far behind. In trial 2, the notebook paper still traveled the longest distance, the copy paper actually traveled the next longest distance, and the newspaper was last. The notebook paper came in first in trial 3, followed by the newspaper and the copy paper. Trial 1 and trial 3 show very, very similar results. Trial 2 could have been skewed by the wind, or maybe we didn't throw it exactly the same. Now that we've analyzed our data, it's time to draw a conclusion. A conclusion is your end result. What happened based on the data that you collected, and maybe even why you think it happened. You could test that even further later, and you can mention that in your conclusion. So let's draw a conclusion. Another main point of the conclusion is to prove or disprove your hypothesis, or what you originally thought was going to happen. So this was the conclusion that I wrote. I wrote the paper airplane made of notebook paper traveled the longest distance. The data shows the type of paper does have an effect on the flight distance of paper airplanes. So my hypothesis was correct. But if my hypothesis would not have been correct, I would have had to go back to the very beginning, rewrite my hypothesis, and test again until I got the right results. Luckily, I was right today. The final step of the scientific method is to write down your findings and share them with the scientific community. So, because I'm not super fancy, I'm not going to write a huge report, but I made this video to share my findings with you. So that's sharing my findings with the scientific community. But guys, that's basically how you perform a logical and well-planned experiment. And now you guys are going to get to sort through some scenarios of your own and plan some experiments.